So before I dive into the lecture, I asked for, down to the wire now, basically tonight and a couple weeks, 3 weeks. I'm not going to talk about the final week yet. I'm going to highlight most of that beginning next week, but the next 2 weeks will be pretty light, um, so I don't chase anyone away at the end here, and that's the whole idea. But anyway, first thing I'd like to do is to review Module 11. It wasn't that much work, but there are some issues. So first thing that I'd like to take a look at is everyone did good on the Module 1, but let's take a look at Module 2 assignment. I know there's possibly some confusion there, but I think most everyone caught on what I was trying to get you to accomplish. All right, so to briefly go through this. Number one was basically using column information. We talked about constraints and all that. And name constraints were applicable at the table. Okay, let me read this so I don't steer you the wrong way. Using column information for the animals table below, so you're creating the table. Name constraints were applicable at the table level. Otherwise, name them at the column level. Define the primary key as the animal ID. The license tag number must be unique. And the admit date and vaccination date columns cannot contain null values. So basically, I'm going to use someone's example of this. So yes, essentially, you could have done it a couple ways. This particular person defined the constraints of your primary key at the table level, as you see here. Primary key, good job. The naming, the not nulls at the column level, pretty easy way, and then the name tag or the license tag at the table level. So that was an appropriate way to handle that. And I don't think many people had problems with that too much. And then you were asked to enter one row using your insert into, obviously. Execute a select statement after you insert the row. So insert into animals, and then remember essentially the whole idea of putting in the values that are not null so you don't get any violations, constraint violations. So, and most of you got through the insert into. There's number 3 that caused some confusion. And basically, I was just asking you, without creating another table, to set up a connection, a relationship between this table that you just created with another table that would be the adoptions table, and just identify a foreign key within the adoptions or within the animals table that is related to a primary key in the adoptions table, and you see here it says note, because you have not actually created this table, no adoption ID primary key exists, but you're assuming that it exists. And I was asking you to do this or show the work from a column and a table level syntax. So once again, I'll use one of you as, so basically the column level create table, you can do it this way, you can do a create table, you can do it when you're running the create table, or you can do an alter table. And basically we're identifying this adoption ID as a foreign key, so you need the term references to the adoption ID in the adoptions table, and that's what you're seeing there. So that would be the column level, and then the table level, you create the constraint. We're here because they're creating the table, which is fine, but remember you can also do that from an alter table. So that's all I was looking for. You did not have to run those those queries because unless you want to be an overachiever, you could have ran that, created the adoptions table with, a couple of columns. I didn't give you any criteria, but that's what I was looking for there, and that was 10 points. And several of you had some issues with that, but and some people decided not to answer that, but that's all right. All right. And then going on to the quiz. The quiz wasn't too bad, but there were some issues that I think a few of you struggled with. So let me review that quickly. All right. So question 1 was probably the highest miss. I will remind you that we learned that your table name must start with the letter. And I think that threw people off. So the only one that starts with a letter is the customers with the $sign. So that was one of the rules. It must start with a letter. So it is D there. I don't think many people had problems with 2 or 3. Let's see, 4, nope. 5, evaluate the sequel, insert into department number, location, name, and these are our values. Which type of constraint will be violated given the description of the table here? And you see the primary key has to be not null, which we're saying essentially that's your department. The location is open. The department name should be not null, but we covered all of those in here. So basically, it does not violate any constraints, right? That would be the correct answer there. I know several of you selected a department number, and we're entering in a department number right there, and location and the actual name of the department. All right. The referential integrity constraint is also called, yes, the foreign key constraint. We went over that quite a bit. 7 was pretty good. 8, insert into department values 80 Tucson null. And if you see null here, you're trying to shove a null into that column, which in this case was your department name here again. And we know that we can't shove null, so a not null constraint was violated with that particular query. Let's see, and then 9. That was good. This SQL query will do what? Alter table employees, add constraint, employee, manager, FK, foreign key, references. So basically, you're adding a foreign key constraint to the employees table, indicating that well, let's see, let me read this. To the employees table, restricting manager ID to match every employee ID. Is that what this does? That constraint employee, manager, foreign key, manager ID, or. So reading through those, I think everyone got this one though. Which one describes correctly what this query does? Who wants to provide me with that answer?
I believe it is Charlie.
Say again?
I believe it is C, Charlie.
C, does everyone agree with that? Adds a foreign key constraint to the employees tables, indicating that a manager must already be an employee.
Yes.
Yes, I agree.
All right. That is correct. I think most everyone got that. Now, number 11, it was a long, drawn-out quiz question. And basically, I'm just tasking you to pretty much go through all the DML, starting from inserting a new department, adding Homer or Bart Simpson, and then basically running into some constraints. And most everyone did well on that. I think only one person did not receive the entire 10 points. So it was just many. Does anyone have questions about question 11? Questions about question 8?
No. If anything, I think that actually helped put together that lesson for me was that last question, because
Right.
now I had to do every step you had taught us.
Yep. And that was the whole
And then it was
purpose.
like,
And it's just
always
a
for me,
matter of
light
going
bulb
through all of
moment.
those
That's how it all works
particulars.
together.
Yep. Yeah, that is correct. All right. So that is our review. Okay. Any questions about module 11? Everyone did fairly well. I don't think it was too arduous or. All right. So let's go back to our lecture. Now we're moving into module 12. And that's views. I know you're all just emanating or generating or emitting excitement about this. Let's see, let me start my. So module 12 is all about views. All right. Our objectives. So our first section is creating views. List three uses. Views are actually pretty even still, just to offer my explanation. Because as a DBA, you can create a view and basically provide access to the view only and not have anyone access the core table. And you can use that on any type of application, et cetera, et cetera. And I've done that. I still do that sometimes now. All right. List three uses for views from the standpoint of the DBA. Explain from a business perspective why it's essential to be able to create and use logical subsets of data derived from one or more tables, which is basically the whole purpose of a view. Use a single database table, create a view with or without column aliases. In the subquery, create a complex view that contains group functions to display values from two tables and retrieve data from a view. Ooh, very complex. All right. All right, so let's look at our purpose. It's always important to understand why we do all these crazy things. Take a minute to look back at what you've learned. Pretty sure you've learned a lot being in our Oracle Academy experience. How easy would it be to explain what you know to someone who hasn't taken this class? I'm pretty sure you're all pretty confident in your abilities. But you should pat yourself on the back. I mean, for a couple of reasons. SQL is still very, very important. And if you can explain any of this, any of the things that you've learned in the past 12 weeks, then you're an expert. So the level of knowledge you've acquired is understood. Well, we're trying to pump up your confidence, but it's truly the individuals that understand SQL and the importance of it. It is a select few, even now. We stated this 20 years ago, and believe it or not, it hasn't really grown that much. So imagine yourself as a DBA of a business. They're still pertinent. Some of them are old guys that have been around for 40 years, but they're still doing their jobs. Actually, they need to be ousted out of there because they're unwilling to learn about AI and machine learning and well, that side of the importance of data. Anyway, what do you do when a manager asks you to make it possible for him to be able to retrieve and input? So the first thing I would say is no. Just tell me what you need and stay away from the database. Of course, they're like, no, I have to do this. I have a dashboard and I need to know how to run specific points and pull specific data from the database. And you just shake your head and say, oh, what am I getting myself into? But anyway, don't make it too complicated. I just want to be able to prepare reports, which is always the case, about all of our operations. Ooh, that may be a disaster waiting to happen. So should these employees have access to all the company's data? No, never, right? How will they execute commands that require join conditions? It's not such a big deal now because they'll run some type of front end that will put together queries. You just need to provide them access. And that's pretty much the scenario now. So it is wise even now to allow data input from, well, it is wise to allow data input from anyone, but you do have to answer the question, or you need to know how to answer that question. So how am I going to allow these individuals or this manager or this supervisor, or these employees to access certain parts of the data without opening up the whole database. Of course, we know we have rules and we have constraints and we have a lot of things to protect the data. But in many cases, you have to build something basically on the fly and make it and create a way that it can be changed. So in this section, we're going to learn about how to create views. Views, it seems pretty straightforward, but it is something that can make your life easier when you're trying to control access to the data. It's probably the most straightforward way to create something that's maybe temporary, maybe it's not something that's going to be static across even a day for that matter. I will say in the era of AI, and which is not necessarily definitely not replacing the database administrator, but something like a view or even the need for a view may be lessened some depending on how the database is managed. So that's my comment about that. But what is a view? A view is like a table, or like a table, it's a database object, just another object in your database. And views are not, and this is very, you can't really say it's a table. It's not real tables, but you'll see it is based on table information or mini tables. And that's, you can kind of get an idea of how the views are created. So they are essentially logical representations of the existing tables, or even of another view, which I've done over and over. Views in and of themselves contain no data. You're like, wait, what does that mean? They function as a window, which is where the name came from, through which data from tables can be viewed or changed, dynamically even. I mean, I've run into many scenarios where I've had to change a view, change the query within a view. I mean, even automate it in a way that it satisfies certain conditions, but we'll talk about that. I'll try to make it less complicated with some of the views that I've had to create. All right. The tables in which a view is based are called base tables. Whoa, look at that. Look at that. That verbiage can be pretty tricky. Yes, base tables, remember that. A view is a query stored as a select statement, and we all know select statements, and it's stored that way in the data dictionary. And here's, we're going to talk about the syntax, but you take a look at this query on the left, create view, and the name of the view and then it's just a select query. And that select query can be as complicated or as simple as necessary. And now you have an object in your database that's in this case is labeled view employees. Well, it's basically another way to view the employees table in our case. But we just created a subset. We just wanted the ID, the first name, the last name, and the email. So we could even rename that view to be something appropriate to that particular part of the employee's database. So create view, and then give the view a name. You don't necessarily have to name it view, and then whatever you want that view to look like. Is this the same as temporary tables? Not necessarily. A view is stored as an object, and a view can be as complicated as needed. And this is an abbreviated view of the view results. And yes, it becomes an object. So select star from view employees. Yes, it's now this subset of the employees table. So you're thinking, well, why use views? Well, the biggest thing, you can restrict access to certain parts of your data. You can restrict access to certain columns. You can reduce the complexity of executing queries, especially if you have large databases. So, for example, a creator of a view can construct a join anything within that view itself, and basically that becomes an object. All the user needs to do is just query that view. And it seems relatively straightforward, but you do really need, if you're the database administrator or even a data analyst, you really need to control how those views are used. Generally, whenever there's like an instance of embedded code or something like that on the front end, it's generally because it's actually, and even with Oracle, it's actually faster to access a view than it is to deal with the entire table, and that should kind of make sense to you, that, you know, from a common sense perspective. Views can be used to retrieve data from several tables. Hence, yeah, you have joins or subqueries or whatever, and you can essentially highlight it for independent users. Usually, during my database administrator days, I would have a list of views, 25 views only used by this list of employees. And all they need to do is either run some type of front end or batch job, and they never have to worry about a problem with the view as far as the data. So views can be used to essentially indicate or showcase data in different ways, hence the purpose. And once again, once you create a view, it is truly an object in your database. All right, so to back up a little bit and take a look at the syntax. So the create or replace, force, no force, and we're going to talk about all of these. The view, and you give it a name, you can give it an alias, and then as, and then it's a subquery. And it's just any select subquery that you can build that will actually run. And I will remind you that if you're creating a view, make sure your subquery will actually create results. Sometimes you create a view on the fly and you don't really test it, and all of the subsequent functions that run for that view are producing data that's not needed. We're going to talk about with check option constraints and with read only, and that's important. Not so much in managing your data, but really whatever code or whatever automation you have running in the background. So here are some of the attributes of the view. Or replace, recreate the view if it already exists. So basically this is how you can modify it. It's an or replace, and so it's create or replace. So you can run that in one query. Force creates the view whether or not the base table exists. Now remember, the base table is what the view is based on. You can force creating a view, which comes in handy if you just want something to test data or some other scenario. No force creates a view only if the base table exists. That's the default. If the table doesn't exist and you don't use the word force, then you get obviously an error, a view creation error. So the view name is your view name. The alias specifies a name for each expression selected by the. So basically, usually what I would do, the view name will be appropriate enough that you don't really need an alias based on scenarios, but you may have a view that has several purposes, and usually you try to stay away from that particular approach to views. But those two are they do kind of the same thing. The subquery it's a select statement that creates a view of the data needed, and you can use anything that you've learned for your view. Generally, it's a select statement, so you're not trying to alter data, which is the key. You're just selecting a little window, a little subset of data, and hence you have your view. All right, with check option specifies that rows remain accessible to the view after insert or update operate. So if there's something happening to the base table, if you use the with check options, it always checks to see if you're in the most updated version of the table or tables. And that's what the with check option does. Constraint is a name assigned to the check option constraint, and you'll see all that when we test it or when we run some queries. With read only, basically there's no DML, update, insert allowed. It's just for read only, just for reporting, and that's if you want to protect it so that you cannot alter the data through the view. Because you can, if you think about it, if you run a update update the view, you really don't want to do that with a view. It's usually designed for a specific purpose, usually reporting. All right. All right, so let's look at an example. We saw one before. Let's look at another. Here's create or replace. That's usually what you want to add as far as your keywords, because if that view exists, you're not going to create any issues. Create or replace our view name as select country ID, region ID, country name, capital, and when location. So this is Euro countries, right? So when the location is like Europe, then you get the indication the view is created. And when you select from the view, you get all the countries that are in our table that are European countries. Just like that. So now you just created a nice little subset. All right. Views are fun, but as with anything within your database environment, there are some guidelines. The subquery that defines a view can contain complex select syntax, which means you can make it as complex as you want, as long as you can run it and produce data, which is why it's a good practice to test that select statement. The subquery that defines a view should not contain an order by clause. Order by clause is specified when you retrieve data from the view. So the order by clause is not in the subquery. Please remember that. That can cause you some headaches if you don't follow that guideline. You can use the or replace option, and I would suggest always using the or replace option to change the definition of the view without having to drop it or regrant object privilege. So we're not dealing with privileges or anything like that with our little scenario, but if you're in a real life database situation, yes, or replace will protect you in many, many different ways. Aliases can be used for the column names in the subquery. So you can, although you probably would not want to go that far, because the view itself will probably just have, core data that can be formatted or whatever's needed after the data is retrieved for reporting purposes, and that's usually the case. All right, there's some features, two classification of views. There's the simple and the complex, and these are kind of the separation of the two ideas of creating a view. So, and it's pretty simple. Simple view is usually just one table. It doesn't contain functions. It doesn't contain groups of data. And you can perform DML, so insert, update, delete. So generally, if you're in a pretty complex database scenario or a pretty large database scenario, you're creating simple views. Complex view is usually one or more tables. It will contain functions and it contains groups of data. So now you're getting a little more complex. And usually the complex views, you're not running any insert, update, or delete. It's only for the simple purposes or the purpose of bringing that data so it can be used for reporting or any other types of display scenarios. All right. So a simple view, as I said before, basically it's just kind of a representation of a subset of the table, and yes, you can do just about anything with it. And usually the appropriateness of this is that there's some type of function and it's embedded in some automated function, and it's just spitting out data for some primary reason. And if you don't need to change it, then it just runs and runs and runs. And you see here, our example, we just have one table, our WF countries, and it's a very simple query for your subquery. That is a simple view. And we saw this before, simple view. And if you want to use aliases in a simple view, like you can streamline the names. Like we have country ID, you want to streamline that to ID, country name, etc. You can do that within a simple view. It just makes it possibly easier to read. I'll say again that usually a view, you're not necessarily reading the data from a view. It's actually being piped to something else where it's being formatted outside of SQL. That's kind of the phase now. If you use any of the dashboards that are out there now, basically it's using the view to pull in raw data is what I'm saying. So it is possible to create a view whether or not the base table exists. Adding the word force will just create a view. Now you're probably asking, well, what is it a view to what? Since a view is viewing something, if there's no base table, why would you use force? Well, primarily I've only used that during development where there's either some testing, referential integrity or something. You don't necessarily use force, usually testing and development. That's all I can say there. It's really, if you think about it, if you don't have a base table, then there's not a lot you can do with a view, but basically depending on, there could be a scenario where you're developing some type of processes and you possibly need to run that functionality. The no force is always, it is the default, and it means that most of the views that you'll see, even the high-end ones, are based on a base table or tables. And kind of contrary or opposite or adjacent to that is our complex views. And really the only thing that makes it complex for the most part is usually you have something like a subquery or joins, and it involves more than one table. And so here in this example, we have two tables. We're using, what are we using? We're calling it view Euro countries, country ID, country name, capital region A from WF countries, and we're joining WF world regions. So it's just two tables. Now all of a sudden, even though the query is not that complex, it is essentially called a complex view because you're using more than one tables. Okay. And that's our view. All right. The other aspect of views that you'll run into is that they can involve group functions. Group functions always puts it at another tier because there's some rules that you have to follow. So you see here our subquery is we're using max, we're using an aggregate function, and we're grouping it by region ID. Whenever you have anything like that, as far as any group function will invoke a need for a label of complex view. That's all it is, but it's not really a complex query, as you see. All right. All right, modifying a view, pretty straightforward. Essentially, you always want to, I would suggest, if you're out there, you always want to use the or replace, and that way you're always modifying. And basically, if you use or replace and that view exists, you just, as it's stated, you're replacing it with your newer version, and it immediately replaces the view, etc. So, all right, so that's it. That's how you get started with creating a view. And here's our terminology from this section: the alias, complex view, create view, force, no force, replace, simple, complex, subquery. Remember, the subquery is the key here, the view and the view name. All right, deep breath. DML operations and views, once again, not necessarily the best place to run DML. Remember, the DML is the update, insert, delete, but you can do it through a view. As a database administrator, you probably, if you're controlling the tables, yeah, you probably want to run your DML on the tables, not through a view, but there could be other layers involved. We're going to look at that. We're going to look at name. Then we're going to look at the conditions restricting your ability to modify view. As a DBA, there aren't restrictions, but maybe you have to invoke those. We're going to write and execute a query using the with check option. You get to see what that does. Explain what that with check option as it applies to integrity constraints and all. We saw this before. It's kind of the same thing. And then the with read only. I can tell you right now, every view that I created within a large company structure was always read only. So, which means you can't run any DML, even though we're talking about DML. So you can't make any changes to the tables. And there's a reason for that. So as we learned the last lesson, view simply, basically it provides an access or restricts, or you may be able to restrict access using just a view. As a DBA, if you happen to become a database administrator, Yes, this is one of the things that you have to worry about, and that's security, securing the data. Who has access to what? All right, so as you know, DML is the insert, update, delete, as I said before. Anything that changes the data, once again, I'm almost hesitant to talk about this with a view because sometimes we forget about what can happen within a view and what type of access, etc. But that's all right. We're going to open up the floodgates and say, do whatever you want with those views. I've never done that, but you never know. Anyway, so this view shown on the right was created for managers in Department 50, which happens often. Managers always seem to think that they need to have access to all the data all the time. So you just create a view for them and say, leave me alone. So anyway, create or replace this view Department 50, and we're just giving them access to Department ID, Employee ID, first name, last name, salary, because they want to create a report and see who they can dock pay or give a raise. And think positive. So once again, we just create a view, something for the manager to take a look at. All right. Whoopee. So using the view as stated, it is possible to run DML. It is possible to change the value, change the data through the view, which actually changes the base table. Remember that, unless there's some restrictions on it. So essentially, you have two pretty good levels of restriction to ensure that you're not changing the validity of the data through a view. So the two restrictions are with check option and with read only. Once again, most of the views that I've created have always been with read only. And this view that we just created, so if we define this with check option, see, make sure I state this right. See, what am I doing here? It's the same view, our Department 50. We're going to update it. We're going to run a DML. We're going to update Department 50, set Department ID equal to 90 for this employee. So you have to remember, this is going to actually update. And however, what if we have restrictions and all these things that, you know, we can run into? So in this case, the employee that were, well, supposedly they're not in this department because we're going to change them into the department. So with check option, basically we can do something like that because they're not really a part of the view, but they are a part of the base table. That's a little bit confusing, but without check option, if they're not a part of the view, then you would get you would get an error. All right. So the way that you create that view with check option constraints so that you will not produce an error. I'm sorry for jumping a little bit. Basically, when you have the with check option enabled, as you see in the syntax below here, whenever, if the data is available and appropriate, especially something like this where a particular subset or the data within the subset is not a part of the view, then basically with check option, it goes and checks the actual base table, et cetera, or the connection between the tables, and you can actually create something like changing departments. And you see here, it's with check option constraint, and we're just modifying this view with this check constraint in it to make sure we can run any type of operation on the DML side successfully. Hopefully that makes sense. So backing up a little bit, if we have the constraint on there, the check constraint, and so maybe I'm contradicting myself a little bit. I said it in reverse. If we have the check constraint on there, I'll correct myself. And we try to add an employee to the view that's not a part of the view, then we would get their basically telling you that the check constraint is on. You cannot do this unless you take the check constraint off. And that's where it's a little bit confusing. but it does protect the validity. This is one constraint that protects the validity of the data because you're trying to modify this table through the view. Hopefully that makes sense. And that's one of the restrictions. The other restriction is the read only, and this is the highest level of restriction on a view. If you add the with read only option, as you see in the top here, basically no DML, no insert, no update, no delete. You get an error message saying that it is not allowed. You cannot perform DML. And as I said, most of my views that I created, there's no need for anyone to alter the data. So I would put with read only. And Oracle, I mean, most database systems, you can't do this. You actually have to add in a constraint on the base table, and it becomes a little bit more cumbersome. But so with read only, no DML. Best thing you can do for a view. So the difference between restricting well, views should be restricted in my mind. For simple views, you may want to open it up a little bit for DML, possibly. And my DBA days, no. But complex views, no, because that's usually something very specific to the data in those base tables, and you really don't want to have anyone modifying the data through a view. That's truly a restriction. That's the one thing you're creating a view to restrict access to the data itself, and especially to restrict any type of modification of the data. So going through the restrictions a little bit more, when you're adding any of the constraints, basically, to summarize this slide, you just have to be very, very careful. Things with group function, because you're opening yourself up in many ways with these views. So you do want to remember that actually restricting the DML processes is a good thing. And that's all that I'm going through here. It's best to not have the data modified through the view. Now, if the view contains group functions, group by, distinct keywords, pseudo columns, any of that, basically you want to restrict any DML. So in essence, in my history, I would restrict all DML functions within the process of dealing with the view. So these are some of the reasons that Oracle says, well, if you have this, then make sure you restrict. And the lesson here, if you're going to create a view, I would say add one of these right away. That way, and then just disallow any DML. At least that's my history. If they have access to the tables, then they can change the data. Otherwise, it's a read only. It's a scenario where there's really no need for them to offer. There's other ways that the data can be modified, not through a view. So that would be my general policy. Okay, last section of this module, managing views. So create and execute a SQL statement to remove a view. You can probably figure that out. You can write an inline or create an inline view and create and execute a top-end analysis query. Top-end analysis, not used that much anymore, but you'll see some of the usefulness of it. And I think eventually Oracle will decide to update some of these particular core level practices. Just because many of these practices are being automated in different ways, but it is important to note their usefulness. All right, so learning and creating views wouldn't be complete unless you knew how to get rid of them, right? The second sentence, views are generally, even now, they're created for a specific purpose, period. There's not ambiguity, there's no ambiguity there. It's like, this is what I need a view for. And usually when some developer or someone who's in analytics will say, I need a view with these data points, and you have to build it. But that may be temporary. So if the view is no longer needed, you need a way to either change it or get rid of it. Here, the example of an employee who had access to financial information leaves the company. That always causes a lot of work. You have to delete their access to everything, make sure they can't sneak in the back door, all kinds of things. And then we're going to talk about inline views and how that can be used. All right, so deleting a view, and it says, it's stated here that it contains no data. So removing it does not affect any of the data. And that's true. You can just essentially delete it, and you're not impacting the base table. So yeah, it's like hitting the delete button. So yes, the syntax is pretty straightforward. Drop view, view name, gone. Yep. And so we all know what drop really means, and you can, rescind that or restore or anything like that. But generally, if you want to get rid of a view, and views are pretty straightforward. I mean, it's because they're created and dropped all the time, and even now. All right, so I mentioned this inline view. What is that? It also refers to as a subquery in the from clause, that hence the inline. So you insert a subquery in the from clause just as if the subquery was a table name. And you're like, oh, what does that mean? These are commonly used to simplify complex queries. In some instances, not a whole lot anymore, but you can use them to remove join operation and actually condensing several queries. So if you take a look at this example here, as you see here, select. So this is just a subquery example, right? Last name, salary, department ID, max sal from employees, and then we create this inline subquery, and then in the from clause, where employees from employees, and then the select department ID. So we're actually creating kind of an inline view without even calling it a view. So it's just creating a condition, an additional way to look at this data through that nice little subquery in the from clause. And we've seen these before. That shouldn't be too much of a surprise. So if you run that subquery, select department ID, max salary as max sal, remember that's just an alias, from employees group by department ID, you get this group of max salaries, which is the same as essentially your salary if you see the salary in that department. So without confusing you too much, basically, we're giving that whole little subquery here the alias D. This is where you get D from in this max sal. If everyone sees that, and max sal is just the max salary, so it's an alias. So we have that as a column name in this overarching or outer query here. And we're basically, and of course there's simpler ways to do this, but it's kind of a tricky way to do a join using an inline view. All right, top-end analysis is a SQL operation used to rank results. And basically, if you need to run a query, it's not necessarily a view, but it's kind of in the same vein. The use of top-end analysis is useful when you want to retrieve like the top records or do something ordinal. And it's simply that. You see here we have, if we want to run this query, select row number as long as employee, last name, hire date from employees where row numbers is less than equal to 5, or so that would be the query that we would run if we wanted to rank the employees that have been there the longest, right? You can change that to a top-end analysis query. It kind of uses what we call our inline view, which is basically a subquery. Hopefully you got that hint there. And you can use the row num, which is a function, and that basically returns the number of rows that's specified for that function. So our row num is less than or equal to 5, so it's going to return 5 rows. And you're essentially creating the same thing that we did in this query. But that would be a top-end analysis. Do you need to make it that, well, for our little example here, you don't necessarily need to utilize a subquery to create this result, this result, but that's what a top-end analysis is, right? So essentially, what I'm highlighting here is the whole idea of an inline view. It's not necessarily, once again, it's not call a view, but that's actually, remember, that's from, and usually what follows your from clause is a table, right? But we're creating a kind of very temporary inline view. Can be a little confusing, but all it is saying, this is our nice little snippet or subset of our table employees. And hopefully that makes sense. All it is, instead of creating a view, you're just doing a subquery, right? In your select query, or you can even run DML if you're brave enough. But this is labeled as top-end analysis because we're trying to order our employees that have been the longest at Oracle the longest. Any questions about that? If we're all still awake. All right. So our terminology for our last little section of views. This will give you a good introduction to views. Views have become, I don't know, they used to be very, very useful because of how you can change them dynamically and how they're persistent, and they're actually an object within your database. So drop view, inline view, top-end analysis, and roll down. All right. See, that wasn't too bad. All right, so let's take a look at what's in store for this week. As far as like I said, it's not too bad. But once again, we're coming down the wire. Next week is May, so we start May 4th, lecture May 4th, right? And then May 11th, next week is May, right? Is that correct? So we technically only have 2 lectures left, but next week, well, I should have combined. We're in section 12 now, and then 13, and then 14 is the big week. So we have 1. Let me quickly go over what's left. So we have this week is our views, before I get into what you're required, and then we have sequences and synonyms, and then we have our big week. I will start the conversation about the project and the final the next week. And then we have our final lecture on the 11th, and then our class ends on the 15th. So please kind of prep yourself for what's coming this week, next week, and then we're basically in our last week, which is May 11th. So that's all we have left. And then, yes, you have the final exam, which is that week. You have the whole week. I think it opens on Monday right after class, and you have the whole week. And we'll go over that. I'll give you kind of a preview of that next week. And then basically the last lecture is talking essentially a brief lesson about privileges, regular expressions, and TCL, but nothing really heavy, even though we have a lot going that week. And then the final project and final exam. The final project, don't sweat it. It's just following directions, building, kind of a new sub schema, we'll call it that, within our schema. And you just follow the instructions. So there's no need to sweat that. Anyway, let's get into our week this week, our views. We have our practice, and no videos this week, so I bet you're happy about that. But there's some practice queries in here. That's useful. The practice queries are always useful. I mean, if you're not running some of them, you're really doing a disservice for yourself. And that includes the practice exercises and the sections. You probably know this by now, a lot of what I put in the assignments and the quizzes comes from these practices. So hopefully you're paying attention going through those. There's the three sections that goes with the three topic sections that we went over. And then the assignment, yes, just one assignment. Look at that, 3 questions. Although you have to create a view and it's, yeah, pretty light. 3 nice little questions. You all can handle that, right? No one's going to skip that. So I'm sucking you all in, making you all feel comfortable, and I'm going to slam you at all these things the last week. So, so feel happy about that. And then we have the quiz for the week. And then we get into May. We get into the last stretch of the course. So there you go. This week we hit views. So I'm going to stop sharing. Any lingering or ongoing questions? As I said, we're coming down the wire. You guys you're all doing very well. So I'm really happy that I got a chance to teach you SQL. The last 2 sections is just mostly residual. Hopefully you can look, well, I will just say begin to look back to everything after the midterm, because that's what's on the final. It is not cumulative. It goes from section 9, or I think it's 9, to the end. So begin to think about that. And that's where those exercises, those practices come in handy. Because a lot of those, as you saw at the midterm, and you guys actually were probably one of my top classes as far as the midterm. What did I say? The average was like 87% or something like that. So
I think you said it was 87, yeah.
yeah, so that's the best, you guys. So I'm not worried about you guys. So if you guys can average 87, then you're doing pretty good. And the final's very similar, so don't sweat that either. All right, any questions or comments?
Nope. Today was definitely not as intense as last week.
Yeah, I wanted to give you a little bit of a break because we're coming down to the wire. And I think you've all are demonstrating. I don't think I've burned anyone out yet, although I'm probably on the cusp, right? I was like, oh, I can't take any more of this, but no, we're coming down to the wire. It's not going to be as bad as you may think for the end, but just hang in there. You're all doing fine. So, all right then. With that being
I have a
said,
quick
I
question.
appreciate your attention. Once again, I'm always checking my messages or whatever. If you have a concern, please send me a message.
I think somebody had a
Otherwise,
question.
I'll see you all next week, the next to last lecture. We'll probably, yay, can we just have a big party or something and not? Wow. But anyway, I will see you all next week.
Have a good night. Thank you.
Yeah, take care.
Thank you.